above zeroed out.
Okay.
Grab the remote and load that up. And then we'll try to get it to go strong.
How much way above?
Do like halfway to the top, basically. Now, hopefully YouTube won't crash on us.
Okay, we're 150 above.
Cool. And you got to reference all the X, Y, and Z. Did you already do that?
What does this do exactly
So it goes and hits the limit switch, and then sets that as the machine home position.
Okay, so do I have to do that before or after?
You should be able to manually move it to your X, Y, and Z 0, and check that it's roughly, check that your numbers are still good, right? So if we do, so that looks pretty good.
I think the Z is way off.
Yeah, the Z is going to be way off here. You'll have to do the paper trick again. Every time you load a new bit, you've got to do.
No, I did. I just did it before we re-referenced them.
Oh, well, it should be fine then.
It's way off. Oh no, it should be 150 off.
150 off?
Mm-hmm.
Okay, yeah, so let's see. So Z at 150. Looks good. You know, if there's a bow in the center. Yeah, okay. So then it will be attempting to run it.
Yeah.
There. Okay. Good, good, good. Let's try to run it.
Okay.
And this time we'll have plenty of time with the e-stop, the software e-stop.
Not start program will not unmute. Okay.
That's showing the existing path that it already took.
Okay. Good cycle?
Yep. Maybe it took a little stop. Okay, so that's working perfect. You see, it's starting 2.5 millimeters above the surface.
Yeah.
Just like it was meant to. So I think somewhere in the last process, maybe we forgot to click Z0 or, you know, something like that.
Figure out the camera yet?
I don't know. It's still live now. The live stream seems to be working. Also, there's a delay between that and this. But as long as you can see on here that you're moving, which, yeah, you can see. That's your hand, Sam.
Mm-hmm.
Oh, yay.
Okay, cool.
Hi, Mom. Yeah.
Okay.
So why don't you stop it and bring, let's approach a little closer ghost drawing. Yeah, there you go. So pull your Z down to, I don't know, an even number, right? So, or you know what, just bring it down close. Right there. Good. Zero it out there, and then we'll just manually zero it again before. Or if you want to even it to like -120, then we know it's just 30 off. Up to you.
Oh, it's not decent. Nope. It's getting off my floor.
It's fine.
It's not okay. Okay. Anyways.
Okay. Yeah. Try running the pattern now.
I will. I'll have to start from the top.
Yes. If you do cycle start, yes.
Okay.
You can do feed hold and it'll pause.
Okay.
But yeah. Cooling off it starts.
Okay. Okay. Okay.
Okay. Let it run a little bit.
It approaches it really quickly.
Yeah.
So it's just a little scary.
Just wait till we work on CNC lathing or CNC turning, as they'll say. But yeah, that's a scary machine. We definitely approach it with caution.
Yes, instead of very quickly.
Yep.
Moves through the actual like pattern itself relatively quickly. It's just that we're going so many times through.
That's right. Yeah.
Cool. That looks great.
Yeah, and what we're trying to do now is just get some confidence that it's not going to crash. So if you want, for this, so remember when you open it, it's going to slow down, and it'll pause movement as well. The spindle will slow, and it'll stop movement.
What else are you gonna see?
You can stand from the side to see if it's front and back okay. All right. Try that, and then the other thing you can do is down here, your feed, your RPM, and overall you can have sliders, so we can kind of speed up this testing.
Well, but the other thing is, we want to be able to see the outside. We're doing the inside first.
That's right. Good call.
That's how they get harder to determine.
You can't really see yourself when you're over there, so don't worry about it.
Oh, good.
If you were concerned. I'll go over there and make faces at the camera. And if you can't see that I'm making faces, come wear the mask. Hello. Can you switch your view to the top view? It's awful close to that parallels.
No, this is the inside.
If it's really well gripped and the parallels are loose, I suppose you can slide them out. But also kind of a safeguard that it pushes on and goes there. Okay, there's another way too, which is that we clamp it directly to the bed with a piece of sacrificial aluminum underneath it. That always works pretty well. That's what these are for. Basically, you put this goes on the sample, and then this goes on the back, like this, and that way it's clamping down parallel. Or are we? Three more layers.
Yeah, this should be 7.
Right. Yeah, that's right. 7.4. Now, it'll be a little bit frustrating, possibly, but we also run the risk of breaking the bit. I'll say it's kind of likely because we do practicing runs like this with these cheap little 1/8" low quality bits. But just like your chiffon design, this is just about fun and learning a little. One more.
So the bit does break. Can you do freehold, or you have to figure out where it is in the pattern, or do you just let it go through the rest of it?
If you don't move it apart and it's just a contour cutout like this, you'll restart. Because likely it broke and they kept moving. Now, you could go back. I mean, it depends how involved you want to get. You can go back and pick individual decode lines to start at. So if you, for instance, let's say it broke right now, and then you caught it and hit freehold or hit probably stop right now, then you scroll back up until it was maybe here, and hit cycle start there. But you would have to re-zero the Z.
Yeah, based off where the
That's right.
now it's doing little tabs.
Oh yeah, the up and downs.
Yeah.
Yeah, and I was seeing what the delay is to get up on that screen. Did you see?
So that's actually text again. That versus that.
So this is recording and spitting it up at the end.
Interesting.
Yeah, actually, so that reemphasizes that when you post
They're
process,
truly separate.
yep, they're separate files that are just copied together.
Oh, we should.
Looked okay so far. We'll get ready. So we want to see it when it's in the heel, and the head looked close, but looked like it was going to be fine. I think the head's higher than the wing.
About the same, yes. You ready? You ready? You ready? You ready? You ready?
No, I'm not ready. What?
Okay, now.
Ooh. Ooh, that is close.
Gonna do it again. Oh my gosh.
I mean, I'm pretty sure we're fine in terms of not hitting the vise, but in terms of not hitting the parallels, I don't know that we're fine.
It doesn't slow down if you do that?
No, there's no interlocks on these sidewalks.
That seems bad.
Well, sometimes there needs to be a way that you can weaken the milling sometimes. So we just gotta wear safety gear.
And not have it actually cutting things yet. Okay, it's not at the top of the knife. And quick. Second quick.
Okay, let's stop the rest of you. Let's do it. We're gonna run without parallels.
Okay.
Make sure it's extra tight. All right. So re-zero that Z.
Alright. What do we have it as? 30?
Yeah, pull it over here off the plate, and then go back to where it should be, which is minus 30, I think.
Okay, that looks
right.
much. That looks higher. It's below the.
Oh, you're good.
You know what I'm saying? Like that's too low.
Okay, well, that's why we gave us some slop with that 1 millimeter under. So. Yeah, we'll just zero it again.
X. You having fun there?
I am. Always have. Switch to the small.
Yep. I don't feel like this is not doing it.
It will. And stop. One more. One more. That's good.
Okay.
I don't know. Give it some distance. That way you can really speed up before it hits. Okay. And cross our fingers we won't crash and whatnot again. Knock on wood. Here we go.
Ah! Okay. It's fine, it's fine, everything's fine. I was not gonna do anything at first. I asked you to.
Okay, good. Start 2.5 millimeters above, which is where it should.
That part's good.
You just put that much.
Good call, good call. This would be interesting to keep going.
Yeah, you want. The other thing for safeguarding, you can always turn the spindle on. So that's the spinning ring. So basically, the faster the spindle, yeah, 6,000, has a specific feed rate. And so that's, every time the blade comes around, it's going to take a certain amount of aluminum with it. But if you spin it faster, it'll take less. It's going to be a less aggressive cut. Now, if you're not doing flood cooling like this, you have to worry because the chips actually take the heat away with them, right? And so if you're taking less material, there's more rubbing, there's more heat, and aluminum can heat up and turn gummy.
Oh,
Yeah. And if the blades get filled with gummy aluminum, then they stop cutting and it breaks. But we're using flood cooling, so that doesn't really matter as much.
one. It reset it.
Yeah, in your G
Possibly a
code.
second.
We still have an inch to go.
Inches.
Nope, making contact in T-minus 0.8. For anyone watching, we are cutting out a griffin that Sam made with the inside of a chicken.
Yeah.
It's a griffin chicken pattern.
Gonna become loud.
Actually, you'll be surprised. It shouldn't be loud. Noise indicates inefficiency. Wasted energy.
Yeah, it's not quite hitting it. piece of paper?
About 100 microns.
Looks like a chicken. What?
Let's check to see if we're leaking anywhere. We had a problem with the house and we're leaking some fluid.
Can you see anything from that perspective?
Sure, I think.
I was curious what they could see.
Well, it's not a great video. You know, it's not like we're shooting Avatar 2 and 3 here, but it's okay. What we need is David Attenborough to narrate this.
Still 5 seconds away.
Oh.
So we supposed to sit here and electrocute these
Yeah, again, first time
That's wild.
through CNC stuff, it's slow. So I mean, you can turn up the feed rate. You can turn up the spindle speed as well. So if you want to.
They want to take a break.
Anything that breaks can be rebuilt. Anything that was made can be made again. One example.
What are they doing? Yeah.
So they can see the pattern.
Unless you can adjust this down.
That. It would definitely break when we try and do that. Well,
It looks like a chicken.
So for anyone watching, this is Sam's first time CNC milling, and we're cutting out a griffin with the heart that looks like a chicken. Looks like chicken. This is some exciting television right here.
Oh yeah.
Need a musical number to go with this. Hey,
Hey.
howdy, howdy. You looking for probes?
Actually looking for BNC adapters.
Oh.
We're missing one. Either a BNC or okay. Basically, if you can order for an extra I would love to have. Yep.
Unfortunately, I don't think we've got any.
Alright,
We
hold
got
up.
the banana. Yeah. Got a bunch of random banana and. Yeah.
I know, it's so
Yeah.
and then you get to ordering, and you look at all the pictures, and you're just like, this is all the same, and you get it, and it's like, none of this is the same.
Yeah.
Oh, that's where we go.
Oh yeah, we got USB A, B, and C stuff here. Things are still a mess right now, especially with the public access. But by fall semester, we're going to have it cleaned up and good. By the way, have you met Sam?
No, I haven't yet.
Hi, Sam.
Sam, Rachel, Sam. Sam
Nice to
is
meet you.
MSc Help Me Out with something. So
Oh,
she is
awesome.
learning CNC milling right now.
Nice, what are you doing?
A version of the inside of the chicken.
Sure, the G-code.
Excellent. Excellent. We do that out of 6061?
Yeah.
Nice.
Yeah, just. In fact, I don't even know if it's 6061. It's this cheap aluminum stock that we use for McMaster for teaching.
Yeah.
Yeah.
No, as it should.
So.
Dude, that's awesome.
Yeah.
Yeah, sweet. I'm gonna get back on these days.
Well, you are welcome always. And your child card is now active for whenever to all the
Okay.
makerspaces as well. So
Awesome.
if you want to learn the lasers or anything like that.
Awesome. Thank you much. There's a non-zero chance we might take you up on that for random things.
Awesome.
So, sweet, guys. All right, awesome. Well, back to
Finding BNC connectors.
Well, we're tracking down ghosts in the system. So, and it's a giant ham radio, so it's,
You got enough tinfoil?
yeah, I know, right? You want to tell me, oh, I should have brought my phone up here, why have a 10 microsecond, 750 megahertz pulse that is nodal and does not give a uniform waveform, but only in the upper registers. So I can take the pulse, or I can take the frequency down to about 200 megahertz, and it works fine. I bring it up to 700 megahertz and above, and it breaks down. And we should be getting 1 volt peak to peak, and I'm getting 720 millivolts.
Okay. So somewhere in there, you've got inductance that you don't want?
Possibly. Now the question is which board? We just swapped out the reference board that sends all of the mixed frequencies. And all of those look fine. That's what the signal analyzer was for. So we wanted to see what mixed frequencies we're getting on the 5 megahertz carrier signal.
And that's all looking good?
That all looks nominal.
Well, give me capacitances beyond that have failed, or?
We're literally talking about every single board. The entire thing is a RLC circuit.
Yeah, sure.
Every single component of this is an RLC circuit. So if which inductor, which capacitor, which resistor.
Oh, you know what? If it is a failed capacitor,
Yep.
what's one thing that happens to capacitors when they fail? They heat up.
There's that.
Thermonuclear.
Ooh.
So,
I really wanna.
at a minimum, you'll be able to see if there's any hot spots in the system.
I dragged you down there. I'm gonna show you what we're at.
A double E.
Oh, yeah.
But,
Oh, yeah.
yeah, so it's real simple to use.
Oh, nice.
How long when you want to see. Yeah. Careful if you're getting in there. You don't see what I'm doing.
Maybe not.
So, but
Sweet. Okay.
and it's USB-C, so you guys can do this is a low-cost one. Take a look at the chair.
Yeah.
Chair. Yeah.
Go down there.
A little away from the chair.
There you go.
Now,
Yep.
chair again.
Yeah.
There's the butt frame.
Science.
Yeah.
You also right now.
Oh, yeah.
Oh, well, you're not going to see it.
Oh, yeah. But, yeah, I would look for extra failed capacitance with that. That'll help.
Okay.
So it makes from the first, if you, I don't know, it's okay.
This actually might work. So
What do you mean? Look at how far away from the window it is.
I didn't even think about that.
Yeah, the mill bit, it potentially could have.
Something.
And it also didn't go all the way through.
Then yes, that is exactly what happened. Excellent. So you all of trainings that involve lots of defects. It looks like the bit wasn't held tight enough in the collet, and so it just got kind of pushed up while it was running.
Yeah.
So go ahead and stop.
I gotta bring it into my office one of these days. I was half falling asleep and making basically tees to plug in a bunch of square pipe to, and we didn't quite have it was a big 1-inch milling end. Got embedded too deep. I think I didn't square the aluminum right in the vise when we put it in, and we went too deep on cut, and it chopped or it cut the milling end smack down the center. And I have never been able to get back out of the aluminum block. So that's not on my desk.
Yeah. Okay. So first, let's inspect and check to make sure the bit is not broken. It looks like it's actually broken. So pull it up in Z. So for anyone that's watching, it looks like we broke our bit. We're doing some CNC training today, and we use these very cheap 1/8-inch end mills for training that they break a lot. They look like this. They break a lot, but they're good for training. What's warm? Oh.
It's spinning.
It has been. Tell you what, maybe we'll upgrade since we're a little more confident in the pattern. We can upgrade and use a better end mill. How about that? Let's see.
Did it break?
Nope. My eyes are just not great, apparently.
Actually, you're right. So how do you actually?
So you just finger tight that, and then once it's finger tight, put the other wrench on the top part of the collet. It's this guy. Yeah. Yeah, right there. And now tighten that bottom part like you were.
So actually, go around like that.
There you go.
Okay. I think
Think you're good?
that should be good. Yeah, it does not want to move anymore. Okay.
Okay. Good.
Re-zero the Z. You want to keep that up?
Sure.
While I'm doing other things, so you can actually see what's happening.
So your X and Y are still good. Just got to redo the Z. And again, we added enough slop in the system that you can get the Z pretty close, but it doesn't have to be perfect, and the pattern will still work.
Sure. Oh, I guess this doesn't matter yet, but it will.
Oh yeah, you might as well get it. So again, what Sam's doing here is she's finding where the bit meets the metal
Oh, that's actually
by using a piece of paper
pretty good.
and lowering the bit into the metal. And then when she can't move the paper anymore, or when it rips like that, that means 0. Or rather, that means about the thickness of a piece of paper away from the metal, which is about 100 microns-ish. Again, we need David Attenborough. Here in the wilds of the William and Mary campus, we see aluminum being milled.
Are you starting from the beginning?
1 second, we are out of focus. Yeah, it didn't go very, unfortunately, it didn't go very deep.
Yeah.
So it got pushed up pretty quickly.
Makes sense.
Okay, why are you not in focus? Camera. Focus to me, camera. Can you take a step to your left?
Yeah.
Is that? It's not focused.
Okay. There you go. Okay, now it's focused.
Cool.
Cycle started?
So let's just mentally confirm you re-zeroed the Z.
Yep.
And we still got our X and Y's. Yep.
This time it changed.
Go for it.
Okay, good.
Third time's the charm. Third time?
It's a learning process.
That's right.
You see this out. Me too, you were.
Not particularly, but here, let me change the camera angle. Maybe we can. Hey, not bad.
You can see the outline of it.
Looks like a dog on there. We can get enough, basically distinction between two clips.
Ah,
That being said, this is a side project
okay.
that your brain
Sure.
so this is slicing our preamplifier bandpass filter unit block to certain frequencies. So when we're pulsing on the magnet, we're applying no pulses at different frequencies that go through the basically the signal generator board into the router into the amplifiers, full amplifiers, out into this, which has your duplexer, as well as your bandpass filter into the throat, which basically is an RF antenna. Signal is basically picked up through there due to basically current created through inductance. Comes back through here, is filtered out by a bandpass filter again. Sorry, directional filter here. Goes through the directional coupler into the amplifier and shot back into the receiving unit in a console. We have one of these slices downstairs, the Shelby frequency level 750 megahertz. There's a 50 dB attenuator that is somewhere on board that has blown out on that. One of the side projects, I have somebody early manual on this. I was a chemist who is masquerading as an electrical engineer right now.
Right.
So,
We all masquerade at everything we do until we actually figure it out.
yeah, exactly. So one of my goals for this is a working unit for 400 megahertz spectrometer. What I'm trying to find on here is where the attenuator, multi-attenuator is housed. To see if it's in there and so blinking attenuator for the line. So basically, we need to basically calibrate the cables every time we tune our assets in. So there should be an onboard attenuator on here that we can both lines. Trying to locate it and figure out how we're going to do this. This is why or dating as
Yeah. Okay. And you have any sort of circuit diagram or something?
Yeah. That makes it reflect that much better. Exactly. So I can either use this as before, I can take it back upstairs and connect it. I'm just trying to figure out how much loss we're going to put in. Because that is pretty important. But in terms of energizing the hands-on, sounds like break a bit.
Yep, sounds like a broken bit. Snip it a snap.
That looks like a broken bit.
Yeah. Yeah, we use these like cheap for training, cheap little 1/8" end mills
Yep.
that break all the time.
So,
Yeah.
first time.
Yeah, we'll try it one more time, and if it breaks again, then we'll switch to an actual decent end mill.
Use a good diamond tip.
Yeah. Yeah.
Actually, that sounds a little bit up your alley.
Yeah. What is in the here you go, Sam, put your end mill right there. What is in the closed box? What part of the cartridge?
Question. That's what I was trying to figure out in there. Well, electronics, I can tell you now.
Okay, that's what so the entire circuit board's not.
Yeah, it looks like we have communication ports. Having a little bit of trouble reading exactly what this is. My guess is this is going to be our band pass. Potentially. I could be totally off though.
I don't know. You got a bunch of FETs, and it looks like. Yeah, I mean it could be your band pass because you got some FETs organized in like an amplifier arrangement.
Yep. Or that's the preamp, and this would make more sense that that's our band pass, and that's our preamp, right?
I don't know. What is?
I'm just seeing the RF tuning, RF matching.
Oh, sure.
Yeah. This was just getting a little out of where I could comfortably break down.
Sure.
What's going on?
I'd be happy to take a look.
Okay.
I will give you zero guarantee I can help in English as well.
That's better than I can do, so.
Okay. Cool. Yeah, why don't you leave it here in the middle, if you don't mind.
Yeah.
Just leave it here.
I haven't done anything for the past 2 years as far as I can tell, so.
Actually, leave it here so I can put it on the
Yeah.
Hooray.
Hooray. To give you a little bit of an idea of what I was doing. That's my fun cabinet that we're.
Oh, yeah.
One of those boards was 90.
Okay.
It's so compact at a certain point.
Yeah.
Those are all kilowatt amplifiers, but they're
Oh, yeah. That's lucky.
it's just a pile of heat, so.
Cool.
Cool. That's that. But yeah, let me know if you ever want to come down and look
Yeah.
around it all.
Yeah, definitely. I like science.
You know.
So right now I am resetting the Z axis.
So we also do live streams and videos for the Makerspace and whatnot. So
Oh,
we're live
nice.
streaming Sam cutting aluminum and breaking bits.
No pressure. Yeah. Love that house.
Alrighty.
Cool.
So is it okay for me to take the front of this off?
Oh, absolutely. Just a couple of hex bits. And hex on the end connector on both ends as well. If I remember right, they soldered in the connectors
Okay.
in there. They're pretty easy to break off the target.
Okay.
So,
I don't
which
want
is
to break
fine.
the solders, but
Well, it's
Yeah.
fine. It's just a slight leak and solder.
that's form, you know.
Yep. German company.
I can't resist at least looking onto the hood real quick.
Alright.
Should I start from the top or try to figure it out?
Unfortunately, we don't know where it
Collapse
broke,
down, yeah.
Okay.
and we were pretty early in the recipe, so.
True.
Yep.
Nut,
Yes.
screws, more nuts. That's fun. They soldered into the nut.
Okay,
I will-
look at it.
Yeah, I'll keep it. I know I can find something around there. It took me about 20 minutes to learn it. It probably not changed drastically, but I may use either this information or. Cool. Thank you.
Plan, yeah.
You didn't see the outline of that.
Huh.
Worth trying to try.
I completely forgot that I've got these. I got a whole tray of good 1/8" end mills.
Telling me this now.
Yes. I
What
tell you
makes
right now.
what makes the end mill good versus bad?
Well, so okay. Nominally, this and what we're using are both called high strength steel.
Okay.
That's HSS. But if you were to look at them under our electron microscope, one of them you may see microfractures at the surface. One of them you may not. They'll go through a annealing process, different grinding steps, different manufacturing methods that result in fewer defects. And then, of course, this has a thicker shank, and the type of steel is just better quality, high strength steel.
It also looks like. Well, I guess it's yeah.
Why are these all out here? These all broken?
I didn't do that.
No, it's okay.
This is huge.
Oh yes, that is a double-sided. Here, that goes in here. A double-sided inch high-strength steel, 2 flute. So you can see now the center of the flutes. There's no way you could use this as a drill bit. Yeah, for anyone that's watching, here, let's see if this can use here. So this is a 2 fluted, two cutting flutes, 1-inch end mill. This is kind of an exaggerated version of the tiny little guy we're using right now to cut the aluminum. Yay. You know what this tool is? This is called a deburring tool. It's also one of the sharpest blades in the shop. When you machine stuff, oftentimes you have little burrs left over. It's like a handheld carving tool to carve the edge off, right? It will also carve the edge off the finger.
Yeah.
But yeah, when you're making holes, it rotates because typically you just like run it along the inside of a hole or a screw hole like that.
Oh, so that's my next question, which is how are we gonna get the little tabs out?
So if they come out like they're supposed to, you can just clip them with a little.
Okay, so they are gonna be. They should be fragile enough.
Yes.
Be able to break them pretty easily.
Yep.
Okay.
And again, this is aluminum, so you can cut like with my Leatherman. You can actually cut aluminum like wood because it's fairly. Dang it! Well, welcome to our show. It's How to Break Bits 101. Okay, we're going to switch and use a good 1/8" end mill. Enough of those junky ones. So you're going to be pulling the whole collet out.
Okay.
This time. Oh, actually, you know what? Yeah, pull the whole collet out. Oh, that's the broken bit.
Okay, do you have a smaller one for the top?
No? No, I do not.
Well.
Oh, for that one. Here you go. Oh, you can put it in there. Yep. Load this one in, and then you're going to need to tighten the, after you load it and tighten down there, you're going to need to tighten that as well. Cool.
That'll work.
Oh, hey, Eric. How's it going? Well, no, we're doing all CNC. Yeah, yeah. Yeah, close enough. As long as it'll hit the surface, so it's good enough. You re-zeroed Z?
I did.
Cool. Fourth time is the charm? Fifth time is the charm.
We replaced 2 bits. Replaced 2 bits. The one time that it pushed itself up.
Okay.
At the time where it just went straight down into it. I think we're on the 5th try.
Bye-bye.
Just one a little bit. Until it does anything. I like these, by the way.
Yeah.
I forgot that I was wearing them, so
Oh.
I like them.
Yeah, it's nice. Yeah, the best thing you can have with safety gear that it is, you know, it disappears.
Yeah, it's comfortable and you forget about it.
This is going to be the best Griffin chicken ever.
These are the only ones, but yes. We have the technology. Oh, we're supposed to fix this. The coolant nozzle won't get in the way, will it?
It shouldn't. I mean, the machine will push the coolant nozzle out anyway. And honestly, for aluminum, you don't need flood cooling like this. You need these nice little like misting coolers where it just sprays like mist. Those are nice. But with aluminum, you can even do it without coolant if you get everything set up right.
It really does look like a chicken.
Especially the head.
I know. This part here is gonna break off.
Yeah. The little like leftover bit.
Okay, it should be actually cutting at this point. At least close.
Yeah.
Having the RPM this high isn't what's breaking it, is it?
It should be. I think it's just the bit quality. I do want to raise that
The coolant?
coolant.
See, this is why I said things.
There you go. Now you can see a nice deep trench forming. all the different good bit makes. Well, I'm running this is the third attempt on starting the video too. So it's more like an hour and a half.
Let's sit here. Okay, good.
Sorry?
And your chair was in.
Oh, yeah.
See that, like, doing that, I think? See that? Keep on.
Cool. It's on its third. And again, even though it seems to be going well, you want to be at the ready to hit that e-stop in case something happens. 'Cause it's
Yeah.
further, first time through the recipe still.
Yep. You do have a nice big trench over here.
Yeah, those are good bits. These, the bits we're using right now are these ones, Brew Baker. Here, I'll give you an exact one so you look at it. Hey, Eric. So, how's it going? Oh, yes. Yeah, Sam right there is running how to do CNC milling. He's cutting out Griffin. And we are live streaming it to the YouTubes.
Yeah, I'll look at this. Yeah.
That's the cutout pattern. The end result will look a little different.
So a flat,
Yep.
flat. Fantastic.
Yeah, first time through some CNC stuff, we always just cut out a shape.
Let me break this. go back and look at this in more detail.
It's doing its final pass of the intercuts.
Yeah, so what we've done, what I should say Sam has done here is she's gone through the entire process of, from scratch, designing the thing that has multiple parts. There's an inside and an outside. Generating tool paths and setting up the speeds and feeds for using specific cutting bits. And now,
including depth and everything else.
depth, all that.
Does it do depth when it's over the thing, or does it come back and do another depth later?
Yes to all of the above. There are different ways you can set it up. The way that she has set it up is that it is continuously doing the pattern and going
And
down.
deeper as it goes.
Exactly.
But it lifts in between, obviously. Otherwise.
No, it's one for this particular recipe. It's one continuous cut.
So it starts deep.
Oh no, it starts at the top and then goes down into it.
Okay, so it never is going to retrace something that it's already cut, because that would cut it deeper. I'm just trying to understand how it actually.
Well, so that's what it's actually doing. So if you want to cut a circle,
Yeah.
then what it actually does, you can just go down and then cut the circle,
Yeah, I see.
right? But what this is doing, because it's deeper than it can do in the single pass, it's cutting the circular pattern over and over and going deeper each time. Yeah, the rule of thumb is that for any given bit, you can only cut as deep as half the radius, half the diameter. So if this is a 1/4 inch bit, you could only go an 1/8 inch deep.
And that material is
This is steel.
just steel.
Yep.
Nothing special.
No, yeah, just high strength steel. And the other thing is,
I went on the answer.
great.
It's gonna be a little while.
Yeah.
Just to ramp up to it.
The other thing with milling is, so this is not a drill bit. If you notice, the center of this is flat, so you can't actually go straight down. But even if you want to make a hole, you have to do a helical pattern like this.
Right. Yeah, I've never seen this operate. This is neat. And the material spilling across is just a coolant.
Yep.
It just gets recycled and recycled.
That's right. So it's a watered down version of those tubs down there. It's a synthetic coolant. Back in the day, the history of machining and is the history of precision. It's pretty interesting. And the original machinists would use animal fat as coolant.
Mm.
And even some types that you can still buy today, they will go rancid if you let them.
That's interesting.
We're using a synthetic.
When I was much younger, probably junior high to high school, my dad had a machine shop operation that he supervised and something else, but it was in another building. I used to wander out and watch these guys that, the blue aprons and do milling. But it was what you said. It was do all the cranking, and then things would chunk off, and then come back and do it again. That's the last time I've actually seen milling happen. That's neat. All right, so this is for your wall in your house or something, or?
Sure.
So we're training the trainer today.
Okay. All right.
Okay.
Yeah.
Yeah. So she's going to help me train other students across campus this summer. So,
Can you look over there and make sure it's still good?
yes.
Outside.
Yeah. The pattern is just about as big as you can possibly fit. And if it goes any further, it'll hit the vise, which is a very hardened steel. Yeah, not good.
Not good. Something will give.
That's right.
Right. Okay, well, I'm glad to cut you in.
Yeah.
Are you having people come in other than just one-on-one? Are you having groups come in yet?
Not groups. We're staying to few to individuals or few at a time. We have had last week there was some activity in here. I'd say 6 people at most in the room.
Well, I think we're going to hear an announcement from our fearless leaders later this week about letting up on the mask mandates. If everybody's immunized. And I'm looking forward to that one.
Yes.
And it will be an honor system about if you are, and then there'll be this part about that if you'd rather wear a mask, you can, or if you're not immunized, you should. And you're not to infer anything about anybody who's wearing a mask. So we're supposed to be nice to each other.
Anyway, I don't know, yet, about the date, but I think we'll get close. At least let's put this one, Dennis and I recommended that, and we'll see if it happens.
Excellent.
Take care, see you
All
later.
right, see you, sir.
Here we go.
Yeah, okay. Luckily, I hired student employees to work it up with me.
I mean, I'm pretty sure it's leaking here too.
Generally, you can do like a short milling and it won't leak too bad. You can spray it for a little.
Okay.
Let's see how it's going to do.
What's up?
I'm just looking at it's at its lowest point now in the
Yeah, how's
Y
it look?
axis. No, I think it'll be okay. I think it's going to make it.
Let's start cutting. Yeah, you're good. And that's not alright. There we go.
So for anyone that's watching this, Sam here is learning how to CNC mill and is cutting out a griffin of her own design out of aluminum. In case you're interested, CNC milling is an operation where you take a bit like this and you cut away material until you have something that you want. Like attractive manufacturing. Like whittling. Reminds me, I whittled myself a axe handle for an axe that I have at home, and was practicing throwing it this weekend. It threw really well, but then the axe handle broke, so I have to whittle myself a new axe handle. Good story, right? And here on Tuesday, took the waitress.
The head cleared, which is good.
Yeah.
Just checking. Good.
My 2-year-old son heard this. He would think that it was sirens, and he would keep saying, "Fire truck, fire truck, fire truck." No, it's not a fire truck.
Well, I think kids are that age and they only have schema for so many things.
Yep.
My cousin, but almost everything was a dog. But he didn't know the word for dog. He was taught the word Ohana, which is the name of a very specific dog. And so he just like, Ohana, Ohana. I was like, I don't know.
Yeah. And any big animal that's outside goes moo.
Oh, good.
It's a cow.
Sam, Mr. Dog?
Moo.
you see the outline mixed up where the coolant is settling?
Yep.
According to this, we have about 3 or 4 more layers. I forgot the other. Oh, that reminds me. We're picking up extras of these.
Oh. Where do you think they should be? Probably good to know. Well, they're saying stop by small home. So, one here is the rest. But where do people go?
I have no clue.
Yeah, next time you have class, can you just take one and stick one up over, or you're taking it over there?
Yeah.
Yeah, just stick it up wherever you're taking class. That's good.
Did you break it?
Yeah. Almost done. I heard the first
Yeah. Just the last row. Yeah. Probably not cutting anything.
Most of the time, yeah. In fact, you should be able to see the bit below the surface.
Can you?
so much water, I can't really see anything. Any idea what that sound is from?
It's barely making contact with it.
Yep. Why would it be barely making contact?
Oh, because it's putting up like a very thin layer at the bottom and its sides.
Yeah, possibly. I'm gonna guess that sound was because it could have used maybe one or two more tabs, and the little parts of it are kind of sitting out there vibrating.
Gotcha.
Yeah, like that tail, and some of those parts are just long and dangly. Legs.
Gotcha.
Aha! Woohoo! You want some gloves?
Sure.
If you want, I don't know.
I already have corn all over my
Okay.
Aha! Let me not do that. Which way? This way. No,
Counterclockwise. Yep.
Oh my gosh! There we go. Ta-da!
Woohoo! Now we just got to pop it out.
Yep. Get rid of the last little bit of tabs, and that should be good to go.
Actually, might as well do it in there. I'll go get you some metal snips to clip it out.
That little foot there, just work right off.
Nice.
Yeah, but how do I even get at an angle that works?
Oh, will the snips not get in there?
No. No.
No? Okay. Then, maybe such thin metal that we could probably just use. See if that helps. So now Sam is just removing the little tabs of metal that hold things together. We're trying to. Is that going to work now?
Maybe. Yes, but slowly.
Let's get better snips for you.
Tiny clips. I think it's more of this. It's the width here.
Snippy snip.
Okay, we're making progress.
There you go. Just pull the whole part up. I don't know if you want these.
Aha.
Woohoo! That actually looks kind of cool.
Yeah.
Like a griffin with a puppet nose, like the Gonzo nose.
Yeah, it looks like Gonzo. Okay, this one. Very small clearances.
Or paint.
There we go. Okay, and one more. But yes, they are a pain. There we go.
Kaboom!
Ta-da!
Look at that.
Beautiful little griffin thingy.
That is good.
Griffin chicken.
All right. Thanks for tuning in. You guys have a good day.
It only took 5 takes.
Yes, but now you know all the things that can go wrong with CNC machining.
Yeah.
That's what we do this way.